Hello, I'm Anna Steingruber with Consulting Specifying Engineer here at AHR Expo in Orlando, Florida with Tony Gabriele. Tony just gave a presentation understanding and troubleshooting VFDs, so I'm here as a little follow-up, so thank you for talking to us after.
No problem, yeah.
Amazing. So a little bit of background on Tony. Tony Gabriele is an HVAC application engineer for Yaskawa, and he is based in Oak Creek, Wisconsin. He has an associate's degree in HVACR technologies and more than 20 years of experience with VFDs in both industrial and HVAC applications, specifically consisting of quoting, installing, troubleshooting, and support. So in your presentation, you mentioned variable speed for a three-phase motor. How is this accomplished?
Yeah, so it's, can we start over? I'm sorry. Okay, so yeah, so driving a three-phase motor, we apply a VFD to it. And what is
So in your presentation, you mentioned variable speed for a three-phase motor. How exactly is this accomplished?
Okay, yeah, so we take three-phase power, we feed it into the drive, we rectify it, we turn it into the DC power, it's stored on a DC capacitor bank, and then we send that power or voltage through IGBTs, transistors, insulated gate bipolar transistors. You could think of it as a high-speed switch. And what they do is they pulse very fast, very rapidly, thousands of times per second, and they create a square wave. And we modulate those waves to vary the voltage that the motor sees. And we also modulate the frequency, and that's how we can achieve a variable speed on a three-phase motor.
Very nice, very nice. And so the drive will really run this three-phase motor with just the one single-phase input?
Yeah, so if you have a single-phase input, a lot of technicians or people may not realize that you can drive a three-phase motor with single-phase, which would just be two wires. And the reason for that is because we're, again, rectifying AC to DC. The drive doesn't care if it's three-phase or single-phase. All it needs is DC bus voltage on the capacitors, and then it pulses, again, that square wave or PWM, pulse width modulation, to the motor, and we drive that motor.
Very nice, very nice. And so you also mentioned input phase loss could be caused by an output condition. Why is that?
Right. So input phase loss may lead you to believe that it's an input condition, which I would agree is probably generally the case, but because of the power structure of the drive, if we get into a regen situation, and what I mean by that is if the application exceeds the rotational magnetic field that the drive is creating in the motor, we have turned that motor into a generator. That excess power is fed back to the drive, and it's processed through flyback diodes that are part of the IGBT module, the insulated gate bipolar transistor, and that power flows onto the DC bus. If we get into an oscillating load and we're getting it, so now we're driving it part revolution and then it's being overhauled for part of that revolution, that bus voltage is starting to oscillate up and down, and if it gets into an unacceptable range, the capacitors can be damaged. The drive recognizes that as DC bus ripple, which generates that input phase loss. So it could be caused by an input condition or an output condition.
Got it. That makes sense. And does Yaskawa offer specific product training for things like this?
We do, yeah. So I've actually started helping out our training department recently in the past year. One of the things I'm teaching is HV600 Roadshow, which is an 8-hour class. It's designed to get service technicians certified to do startups on our drives, which earns the customer an additional year warranty for free. So it's a nice benefit. But we also have in-class training at headquarters, multi-day classes for troubleshooting, installing programming applications. So a lot of different options. If that's something that you might be interested in, you should probably contact Yaskawa at training@yaskawa.com.
Very nice. Well, thank you so much for the overview and taking the time to talk to us after the presentation. Appreciate it. Once again, I'm Anna Steingruber with Consulting Specifying Engineer. For more information on VFDs or other HVAC applications, check us out at www.csemag.com. Thanks, and talk to you next time.